Okay, we're going to go over the second part of the front page, questions 7 through 14. And we're coming over here. Let's see, get that where we can see the problem. Keep in mind that whenever you're working on these problems, if you need to do a mole-to-mole ratio, you look at these numbers of moles, which I'll go ahead and fill in just 1 mole for those, where there's no coefficient. You use this for the mole-to-mole ratio. So first off, let's see. In this problem, if this many moles of hydrochloric acid, HCl, now 8, that's our given. I'm just going to label this given. And up here, given, I'm just going to do that up there so I know that that's HCl. Completely react with calcium hydroxide. Okay, so how many moles of water are produced? Now, they're saying it completely reacts with calcium hydroxide. Okay, we don't really care about that. It's just saying it's reacting. But what we want to find is how many moles of water. So that's what we're looking to find. So I'm going to circle this. This is our find. So in this problem, let's see, we're going to be starting with moles of HCl, and we're going to be trying to find water. Hopefully you've got your summary page set up with an MVP triangle. So in this problem, we are given moles, so we're going to be starting at moles, and this one's going to be moles of H2, I believe. Was that right? Oh, HCl, excuse me. Okay, I'll just label that in. HCl. And let's see, we need to find how many moles of water produced. So we're jumping over here to H2O. So fortunately, we're at moles. Start here. We're going to end up at moles. We only have to multiply it by 1 conversion factor, and that's going to be the mole-to-mole ratio. And remember, you always look at the balanced equation for that. So we're going to put the given from the problem, 0.86 moles of hydrogen chloride, HCl. We put that over 1. Now we got to multiply it by the mole-to-mole ratio. So we want moles of compound B, which is the one we're trying to find, which is moles of water from the balanced equation. And on the balanced equation, we have 2 moles of water, so we want 2 moles of H2O up there on the top. And we need to divide that by the moles of compound A, which is the one we're starting with, moles of HCl. And there's 2 moles of HCl. Now remember, this mole-to-mole ratio part of the conversion, you always and only look at the balanced equation. So, and that was supposed to be mole in there. So we got 2 moles of HCl, and that cancels. That tells us, oh, and look at here. The 2 and the 2 could cancel to 1 and 1. And there's a 1-to-1 ratio of HCl to hydrogen, because for every 2 moles of HCl, you make 2 moles of water. That cancels down. So if we start with 0.86 moles of HCl, we're going to end with 0.86 moles of H2O. That's how you'd set that one up. Okay, the next one. If 35 grams of calcium hydroxide are completely reacted, that's our given. Now I'm going to come back up to the equation before I'm going to erase where I wrote given and find on those. So now the given is calcium hydroxide. Calcium, and there's hydroxide. This is our given now. How many grams of calcium chloride? Well, calcium Ca, chloride's that, so CaCl. Oh, and there's the 2. Okay, so this is what we're trying to find. And I'm going to label that find up there. All right, so let's start always, to take a look at the MVP triangle. We're at grams of calcium hydroxide. In fact, I'm just going to make a simple MVP triangle down there. MVP, make the jump to 1 compound, MVP. So we're starting at grams of calcium hydroxide, CaOH quantity 2, and we're trying to find how many grams of CaCl2. So we're starting at grams, we're going to have to convert to moles, do a mole-to-mole ratio, and then come back to grams, because that's what we're looking for. So it's going to be like all the practice problems. If we're looking at this one, you're starting over here, going to divide by the molar mass, then you're going to have to do the mole-to-mole ratio from the balanced equation, then you're going to follow this arrow and multiply by the molar mass of the appropriate compound. So to get that set up, well, we start with the given, 35 grams CaOH quantity 2. Okay, calcium hydroxide over 1, that's our given. And now we need to go to the mole, and anytime you're going from the outside to the inside, you're dividing by the molar mass. And I calculated calcium hydroxide. Over here we got 40, we've got OH is 17, we've got 2 of those, so that's going to end up being 74 grams per mole. 74 grams of CaOH quantity 2 is 1 mole of CaOH2. And if I could cancel those two, then I know I set it up right. Oh, let me get that centered for you and zoom in a little bit. So the next step is we need to do the mole-to-mole ratio, because now we've done this step. Now when we got to look at the balanced equation. And one thing you can do too, since we have moles of calcium hydroxide up there, we need to have moles from the balanced equation of calcium hydroxide down there. And that's what we call, that's the given. And we have only 1 mole from the balanced equation. That's where you look at the balanced equation. 1 mole of calcium hydroxide. And we're trying to find in this problem calcium chloride. And there's only 1 mole of calcium chloride. Oh, we got another 1-to-1 ratio. CaCl2. Oh, and that's going to be moles. I keep forgetting to put moles in there. And so now the calcium hydroxide cancels there. That lets me know I set up the ratio correctly. And now on our little triangle, we've jumped over. We're at moles on the second compound. Now we just need to multiply by the molar mass of calcium hydroxide. Since we got calcium chloride moles up here, we'll say we got in 1 mole of calcium chloride, there are, and I figured out calcium chloride, it's 40 plus 70 from there, the molar mass is 110. 110 grams of calcium chloride. Those cancel off to let me know I set it up correctly. And at that point, now on your calculator, you're going to have to do 35 times 110 divided by 74. And that'll get you your answer. I'm not going to give it to you. You can get it from there. Part C now. Let me zoom out so we can see the whole picture. Add a little more light here. Oh, I guess I did get my light on. Yeah. How many moles of hydrochloric acid are needed to produce 100 grams of calcium chloride? Now, this is our given because they're giving us the chemical and an amount, so that's the given. And we're looking for this. We're trying to find the hydrochloric acid. Hydrochloric, hydrogen chloride, and that's up there. So in the balanced equation, I'm going to erase the old givens and finds. Let's see. We're trying to find HCl this time. Trying to find that one, HCl. And we're given calcium chloride. Calcium is Ca, chlorine is Cl. Oh, CaCl2. Okay, this is the given. So we're going to start with the given over 1. 100 grams of CaCl2. And I know it's CaCl2 because you look at the balanced equation up there and it shows you. So we're starting at grams of calcium chloride. So we're starting at grams. We're going to have to go convert that to mole. And fortunately, I think we only have to do 2 conversions because we need moles of hydrochloric acid. In fact, let me, I'll just label that HCl. And let's see, this was CaCl2. So we're starting at 100 grams. According to our arrow now, we need to divide by the molar mass of calcium chloride, which means you need to put its mass on the bottom. And earlier from a previous problem, we figured out that calcium chloride is 110 grams of calcium chloride, or in 1 mole. And if you can cancel there, you have successfully gone from your, you've converted to moles, CaCl2. Now we got to do the mole-to-mole ratio. We got to convert it into moles of what we're trying to find, which is hydrochloric acid. So we need to put the find over the given. Now that's going to be the number of moles from the balanced equation. Cannot say that enough. So the find in this problem was hydrochloric acid, and we have 2 moles of HCl. And the given in this problem was calcium chloride, and there's only 1 mole of that, 1 mole CaCl2. So now the moles of calcium chloride will cancel. That lets us know we set up the mole-to-mole ratio properly. And at this point now, we've jumped from one triangle to the other. And are we done? I think we're done, because we're just trying to find moles of HCl. So at this point, it's going to be 100 divided by 110. It's pretty close to 1. It might be like 0.9 something times 2. So it's going to be fair. The answer is going to be fairly close to 2. I'll let you figure that out. Number 8. Let's see now. How many grams of CO2 would be produced from the combustion, the burning of that many moles, 3.5. So this is the given right here, given. This is what we're trying to find. Write a balanced equation for this. Oh, okay. So first off, we've got to do, well, you know what? Let's see. Well, first we got to balance the equation. So we have C3H8. Now this is going to be a combustion reaction, so we got to add some oxygen, O2. That's going to change into carbon dioxide plus water. So that's what you get in a combustion reaction. And let's see. So first off, we're going to do the oxygens last. That's the trick when you do a combustion reaction. Now we got 3 carbons over here, so I need to put a coefficient 2 in front of that one. And then let's, oh, no, sorry, not a 2, sorry, a 3, excuse me, got distracted, there we go. All right, so we've got 3 carbons there now, and then over here we've got 8 hydrogens. We only have 2 over here, so we need to put the coefficient 4, because 4 times 2 will give us 8 hydrogens. So now we're going to take a look at the oxygens. And let's see, we've got 3 times 2 oxygens is 6 oxygens. And then 4 times 1 is 4 oxygens, which equals a total of 10 oxygens, which means pretty easy, we make that a 5. Okay, so now we've got the balanced equation. Now on your test, this coming up, you're not going to have to balance the equation. They're already be balanced. Now we've got to do a calculation here. Solve for grams of carbon dioxide. This is our given, 3.5 moles of C3H8. That's the given now. We've got our balanced equation. So how many grams? So let's see now. So the given in this problem is over here, given. And we're trying to find CO2, so I'm going to label that find. Okay, so at this point we're at this many moles. Looking at an MVP triangle, we're starting at moles of our first compound, so we need to do the mole-to-mole ratio there. So now since I have moles of C3H8, oh wait a minute, there we go. I have moles of C3H8 here. So we need to have, from the balanced equation, 1 mole, because there's an invisible 1 in front of there, 1 mole C3H8. And we need to see, we're trying to find CO2, and there's 3 moles of CO2 in the balanced equation, so 3 moles of CO2. And moles of propane, that's propane by the way, gets combusted, and those get crossed out. So now we're at 3.5 times 3, so it's going to be, I don't know, around 10-ish. But are we done? No, we want grams of CO2. And let's see, now we got to get rid of moles of CO2. We can say 1 mole of CO2. And let's see, carbon is 12, 2 oxygens is 32. 32 plus 12 is going to be 44 grams of CO2. Those cancel out. So to get your answer, it's going to be, let's see, 3.5 times 3 times 44 grams. So I'm going to guesstimate that the answer is around 440 or something like that. Number 10, percent composition in calcium dihydroxide. So we'd worked out earlier in the problem that calcium dihydroxide has a molar mass of 74. I got that by calcium is 40. We have hydroxide, which is 17, 16 plus 1. And there's 2 of those. in calcium dihydroxide, so I had to multiply that by 2. So it's 74 grams per mole. So define percent composition. We need to do the part divided by the whole. Calcium all by itself has a mass of 40 grams. Okay, we'll do calcium first. 40 grams per mole calcium. And the whole compound is 74 grams per mole. So you get your calculator, and we're going to do 40 divided by 74. And that equals a percentage, 0 point something something. I'm not going to tell you. You're going to have to do it yourself. I'll show you how to set up the next one. So now we've got oxygen. Now we got to be careful. Since we're doing oxygen, in the balanced equation we have 2 oxygens. We got to pay attention to that. Every oxygen is 16, and since we have 2 of them, there's going to be 32 grams of oxygen per mole of this compound. And we got to still divide it by the total, 74 grams per mole. And you'll get your number there, 32 divided by 74 equals a number that you'll 0 point something. Now those will be, we'll change those decimals directly into percentages. And at that point, let's see, hydrogen, we have 2 hydrogens. So that's going to be 2 grams per mole in the whole compound of hydrogen. The whole compound is 74 grams per mole. And so you're going to get, whoa, you're going to get a really small number when you do 2 divided by 74 equals 0.0 something something there. Okay, so that's how you do that. Lastly, I guess this would have been more helpful on the previous one. Aluminum, let's see, balance and identify these. Well, let's see, we'll do the aluminum last because we can add anything we need. The lowest common multiplier for 2 and 3 is going to be 6, so we need to make that 3 times 2 would be 6 oxygens. But a coefficient 2 times 3 is 6 oxygens. Now we've got 2 times 2 is 4 aluminums. 4 aluminums there. And since we're having 2 different chemicals joined together to make one, this will be a synthesis. Number 14, need to balance this type, and we got 1 compound breaking down into 2, so that'll be decomp. Let's see, this was synthesis, this is decomp. Okay, we just got to balance those. Pretty easy since we got 2 hydrogens and 2 iodines. We just need a coefficient 2 in front of the hydrogen iodides. We're done. See you later on this test. Mole to mole ratios. You have to look at your balanced equation and look at the number of moles, which means look at the coefficients. And please make sure you've got this at the minimum. Copy this into your summary page. Good luck. Actually, luck favors the well prepared. Practice, practice.